Hi, I'm David. So for this problem, they give us two functions. F of x is equal to negative 7 over 2 times x minus 3. And g of x is equal to negative 2x plus 6, all of it over 7. And they want us to prove that these two functions are inverses of each other. So before we start, let's ask ourselves, what does it mean to be an inverse? So inverse means that the two functions are essentially opposites of each other. Meaning, if you were to take this function and plug it into this one, everything would end up canceling each other out because they're all opposites, and the only thing we would be left with is x. The reason being, if we start with a number, we plug anything into x, we want to end up back at the same number because everything ends up canceling each other out. So then the only thing we're left with is what we started with. Right? And vice versa. We could also take this function, plug it in here, everything would end up canceling each other out, and we would be left with also just an x. We would be left with where we started from. Right? That's the definition of inverse, is that the two functions, the two equations are opposites of each other. Right? Just like how if you have a negative 3 and a positive 3, they cancel out. Right? So, or like if you had a divided by 2, you had a multiplication of 2, they cancel out, right? So these two functions cancel each other out. And what we're going to be left with is the number itself of x, of whatever we started with, right? So let's start by just plugging this function into this function, right? That is going to be f of g of x, right? In other words, we're taking the g of x function, plugging it into the f of x function. So that's going to be negative 7 over 2 times, parentheses, negative 2x plus 6, all of it over 7, and parentheses, minus 3. Right? We're just taking this and plugging it into the x. We're plugging g of x into the x for f of x. So now we get here, we just simplify. So right off the bat, the 7s here, you can see they'll cancel out because we have a 7 in the numerator and a 7 in the denominator, right? So 7 divided by 7 is just going to become 1. So this will just disappear, right? Same goes for the 2. Because we have a 2 in the numerator and a 2 in the denominator, these will cancel out because 2 divided by 2 is also 1. But don't forget the 6, right? We have a 6 up here, so we have to distribute this 2 inward, meaning the 6 also has to divide by 2. So 6 divided by 2 means that this will end up becoming a 3. In addition, the two negative symbols will end up canceling out, right? Because a negative and a negative will become a positive. So what we're going to be left with here is x plus 3 minus 3, right? And now, as you can see, the plus 3 and the negative 3, well, these are opposites. So these will cancel out. And what are we left with? We are left with where we started with, which is x, right? Meaning whatever number you want to plug into x, let's say 1, 3, 4, 7, 20, whatever we plug into x in the beginning, all of this stuff is going to end up canceling each other out, and we're going to be left with x again. That same number that we plugged in is going to be the same number at the end, meaning these two are inverses. They are opposite functions. So now we're going to do the same thing here. We're going to take this, f of x, and plug it into the x for g of x, right? So this is going to be g of f of x, and that's going to be equal to negative 2 times, and then we're going to plug this in. So that will be parentheses negative 7 over 2 x minus 3, and parentheses, plus 6. All of this is going to be over 7. And now remember, this negative sign is in front of everything. It's not in front of just the 2. It's in front of everything. So I'll add these parentheses here just in case, just to make this clear that this negative sign is in front of everything. Right? So again, we did the same thing here as we did here. We're just taking the f of x function and plugging it into the x inside the g of x function. Right? And now we just simplify again. And we should get the same result. Right? So 2 divided by 2, that cancels out. That becomes a 1. Right? And then we also have to distribute the 2 inward to here, right? Because you still got to multiply 2 and the negative 3. That's going to give us negative 6, right? So all of this, what is this going to be equal to? Well, we still have the negative sign, so we drop the negative sign. The 2's canceled out, so now we have a negative 7 up here. x. And then the 2, remember, like I said, has to multiply the negative 3. That becomes a negative 6. The 6 here still stays the same. We just drop that down. All of it is still all over 7 in parentheses. And now, as we can see, the negative 6 and the positive 6, they cancel out because they're opposites. And then over here, the 7 and the 7s cancel out because they, again, just divide by each other. 7 divided by 7 is 1. So now we're left with negative negative x. Well, the 2 negative signs cancel out and become positive. And so what we're left with is x. It's where we started with. Again, proving that these two are inverses of each other. We can also prove this a second way by using our graphing calculator, our graphing utility. So if we pick up our graphing utility, we can click y equals, and we can type in this function under y1. And then we can also type in the second function, g of x, into y2, right? And then if we press graph, we should see 2 linear equations that show up on the graph. 2 lines will show up, and they will roughly look like this. Roughly, you have this being the f function, and this being the g function. Now, remember, the definition of inverse is that they are reflections of each other. They are opposites of each other over x. So if you wanted to, you could also go into your calculator, into your graphing utility, type in, go to y equals, and go to y3, and type in x. So then we have y equals x. That will show up with a line that's like this, right? This is y equals x, the most basic linear function. So you'll notice that they all intersect here at one point, and that g is simply a flip of f and vice versa. That these two functions, f and g, are just reflections of each other over this line of x. There's also a third way that we can prove that these two functions are inverses, and that's by plugging numbers in numerically. And so here's what I mean by that. So let's make a table. We have x and f of x, right? Let's start with something simple and basic. Let's say 0, right? What happens if we plug 0 in for x in the f of x function? Well, 0 here will multiply this fraction, and anything times 0 will be 0, so this will disappear. And what we're going to be left with is just a negative 3, right? So if we plug in 0, we get negative 3 out from the f of x function. So what that means is that if we also were to simultaneously do the inverse of that for the g of x function, it should be the opposite. Meaning, if we plug in a negative 3, what we should get is a 0. So they are flip-flops of each other, right? So let's test that out. If we take negative 3 and plug it in to the x here, we get 2 times negative 3. That becomes negative 6. Negative 6 plus 6 is 0. They cancel out. So then what we're going to be left with is negative 0 over 7, and anything that is 0 over anything is 0, right? 0 over anything is 0. So what we're left with is 0. Right? And we could do this with a number of examples. We could do anything. We can plug in, let's say, a 2. Right? If I plug in a 2 here, we get 2 in for x. We do 2 divided by 2. That's 1. Right? 7 divided by 1 is negative 7. Negative 7 minus 3, that gives us negative 10. Right? So that means, again, the same thing should happen here, but just the flip-flop, the inverse, the reverse of that. So if we were to plug in negative 10 for x, here we're going to get negative 20, because 2 times negative 10 is negative 20, plus 6 is going to give us negative 14. Negative 14 divided by 7 is going to give us negative 2, and then we got to multiply that by negative. So a negative negative 2 will give us a positive 2. Right? And I could do this all day. We could do this endlessly, but you can test it out yourself. Plug any number in to this function, and whatever you're going to get is going to be the same thing. If you were to take that and plug it into this function, it will take you back to where you started with. It will take you back to x. Now, whatever x we start with here, we're going to go in a giant loop, right? We're pretty much going to go in a giant circle that takes us back to the original x. And it works both ways. And that is how you prove that these two functions are inverses of each other. Thank you.